Hi everyone, thank you for joining me today on this great event. My name is Shira Shamban and I lead cloud security here at SAI. Our company focuses on threat exposure management and mitigation across all platforms. Now, in the next 20 minutes, we're going to talk about a new aspect in data security in the cloud that's been getting a growing attention since we started building a lot more AI applications in the cloud. So let's get started. For many years, our security models have focused on two main states of data. Data at rest, when it's in your database, stored in your disk, you're not using it right now, and it's probably encrypted. And the other form is data in transit, when you're using the network to move the data across. Usually at that point we use SSL TLS, for example, to make sure it is well secured. Now today I would like to talk about the third stage that we haven't been talking about much. This is when the data is in use. This is especially important these days when we're using third parties, data models, LLMs, and our data is exposed to other parties. Could be sensitive data, could be our customers' data. So let's talk about what it means and what we can do to handle this risk. So we're talking about the third state, the time when our data in the cloud is in use and why it is more vulnerable at that point. When the data is in use, this is the moment it is decrypted in the server's memory, in the RAM, and in the CPU, so it can actually be processed and used by our algorithms to do whatever we wanted them to do. Think of it like the highly secure bank. This is usually the way we like to explain. So we talked about the time when the data or the money is in the vault, it is safe, or the time when it is in the truck, when it is also safe because we probably have some armed guards to protect it. But there is a time when the teller has to maybe count the cash, put it on the counter and so on. And anyone with a master key, like a privileged insider, somebody with admin privileges, another component in the application that has high privileges, or unfortunately even a malware, can walk and steal the data or steal the money if we're using the money analogy. The problem is that once the data is in the plain text state, it is visible to anyone on the machine, the OS, the operating system, the hypervisor that manages the VM, any administrator that has high access to the infrastructure and the software that we are running on that infrastructure. We have no way to enforce today protection on this state of the unencrypted in-use data. So let's talk about the paradigm shift. The confidential computing, or CC, this is a hardware-based solution to protect the data, not just at rest or in transit, but also while it is in use. It closes the gap of this kind of a security loop, so to speak. The CC is built on one piece of technology, the TE, Trusted Execution Environment. You can think of it like a secure digital vault that is built right into your CPU chip itself. It helps the processor and the memory to cryptographically seal off that data so we can use it, but also trust that it is well protected. Let's better understand what this means. In the confidential computing, we have two features we want to look at. The first feature is hardware enforced isolation. This means that in the T, the trusted execution environment, it is isolated from everything outside of it. The OS, the hypervisor, the cloud admin, the system root, none of them can access the code or the data inside the TE. The TE is essentially saying you can't come in and you can't even see what I'm doing, what I'm running, what is this data that I'm using. The second feature is runtime encryption. All the data and all the code loaded into the TE is memory, is automatically encrypted by the hardware. It is only decrypted at rest, possibly just for nanoseconds inside the CPU package itself. If an attacker was to dump the RAM while your sensitive data is processing, they would just see some gibberish, some useless data they cannot make any sense of. Now, I know you're probably wondering, how do I know this digital vault is real? How can I trust a server that is running in the cloud, who knows where? You're skeptical, and you're right to be skeptical. And the answer is the magic word in confidential computing: attestation. Attestation is the cryptographic proof that you're looking for. Think of it like a digital handshake, or some kind of certificate that you were looking for. The TE performs this self-check, verifying two things. The first one is that the hardware is genuine, uncompromised, and untouched by the manufacturer. And the second one is that the specific piece of code that you intended to run is what is actually running inside. It takes a cryptographic snapshot, so to speak, of this state and signs it with the hardware key that only the chip possesses. So you, the data owner, can verify that signature. So you don't need to trust the cloud provider. You don't need to trust the cloud provider's employees. You don't need to trust the manufacturer. You only trust what you can verify with a very minimal footprint of anyone who could have touched it. You might be thinking that this data in use problem or vulnerability is a universal problem. It's not really special to the cloud, and you're right. This is a universal problem, but there are two specific areas where this vulnerability becomes critical, even a show-stopping problem, I would say, and confidential computing uniquely solves these two problems that I'm going to explain more about. The first area is in the public cloud. We are here to talk about the cloud. In the on-prem, you own the servers, you hire the team, you have physical access to all the servers, you have the legal control on them. But in the cloud, as you know, you delegate all of that or most of that. We all know about the shared responsibility model, so some things we are in charge of, but others are still in charge by the cloud provider. So in the cloud, after you delegated all of that, you are placing your sensitive data in a shared multi-tenant infrastructure somewhere in the world, managed by a provider who, to a certain extent, has God mode or root access into your entire stack. This creates some kind of trust deficit between the customer and the provider, which is you, the data owner. The confidential computing is our way of saying, I will use your computing services, I will use your resources, but I am removing you, the cloud vendor, from my trust boundary entirely. You will not have access to my data in any way. And this approach is incredibly important, especially in regulated industries and where we are storing customers' PII, PHI, financial data, healthcare data, and so on. So this is where this problem is unique to the cloud. The second area where it is quite unique is in AI and modern SaaS applications, where the data itself is what has the highest value and actually the target. And this is where we have the deficit, the trust deficit, where we want to collaborate, and we have this sensitive IP that we want to protect. So these are two areas that confidential computing gives us the solution that we're looking for, that gives us the assistance that we need in order to keep our data secure, but also keep on using the cloud, keep on using the algorithms and the machine learning and the AI models to actually achieve our goals. Now, this is where it gets really interesting. For SaaS and AI companies, your deep learning model, this is your trade secret, this is your IP. When you deploy it for a client, it has to be decrypted to run. The confidential computing protects the model's code itself from being stolen, from being copied, from being reverse engineered by the host. The AI model runs, but the IP remains safe. I have a really interesting use case that I really like. Think about the secure multi-party collaboration. For example, imagine two rival banks, or even think about two cybersecurity vendors that want to combine fraud data or IOCs to train a more powerful global anti-money laundering or safer cybersecurity products. They can't trust each other. They don't want to show their raw data to each other. They don't want to share customer data with one another. That all makes a lot of sense. The confidential computing can create a clean data room, a safe place for everyone to upload their encrypted data into a TE. The AI model can train on the combined data, but neither organization, neither party, not the bank, not the cybersecurity vendor, not the cloud vendor, nobody can see the raw data. It allows collaboration without giving up your confidentiality or your IP or your PII. So this is a great, I would say, extension of trust. This is a very powerful approach to sharing the essence of the data without really sharing your IP or trade secret. Confidential computing demands a new way of thinking. The security boundary is no longer the network, the firewall, the VM edge, and not even just identity. The new data security boundary is the TE itself. Our trust shifts from a large, complex, software-driven stack to a very minimal and verifiable hardware root of trust. For security teams, this means mastering some new controls. You don't just manage network access, you manage the attestation verification. You implement services that act as a cryptographic gatekeeper, only releasing the decryption keys to a workload after it has successfully proven its integrity via the attestation that we talked about. This technology is the foundation of a truly global, privacy-preserving digital economy. It enables us to enforce digital trust, meet tough compliance requirements like NIS2, GDPR, HIPAA, with the technical controls, and securely adopt or continue adopting the private cloud for even the most sensitive workloads, data, algorithms, and models. So, to recap our short journey together today, we resolved the data at rest problem, we resolved the data at transit problem, and now with confidential computing, we finally have definitive hardware-backed solution to the data in use problem. Confidential computing is a critical enabler for a future where sensitive data can be processed anywhere without having to trust the infrastructure that hosts it, the cloud vendor, or even third-party software. It provides a technical, provable answer to the question, can you guarantee my data is safe even from you? My call to action is simple. If you have a multi-tenant SaaS product, if you're using the public cloud, if you're running AI models as a service, start exploring confidential computing platforms today. The future of security is about minimizing trust, and that begins with hardware. If you have any questions, please feel free to reach out to me on social media or in any other format that you like. Thank you so much and enjoy the rest of the conference.